Dear participant, I welcome you in the countrywide classroom teaching program 2022. As you all know that we already run earlier in last year the countrywide classroom teaching program for the almost 1.5 months, in which the Digambar of Bindu Arts, Commerce and Science College has recorded and developed around 58 e-contents. Those are relevant for the BSc, FY, SY and TY student in a different subject. Similarly, by taking an opportunity of this lockdown and to available expert and different students from the various college around India, Maharashtra, India, uh, we have started this CWCP event once again, and we invite many of the academicians, those are expertise in their subject, as well as in teaching, as well as in the research, to deliver their lecture in this countrywide classroom teaching countrywide classroom teaching program 2022. And we have received an enormous, and we can say that many of the teachers are continuously communicating to allot some different slots for their lectures. So we welcome all their expectation, and we are continuously allotting them to deliver a chance to deliver their lecture in this countrywide classroom teaching program to develop their e-content and to guide the student of the undergraduate classes of the science faculties. I hope that the students within the university campus of SRTM University and their affiliated colleges will take advantages of this countrywide classroom teaching program to enhance their knowledge by attending this live session on the Zoom platform, on this virtual platform, as per their convenience. They may have access to this developed e-content on our official YouTube channel, DBC Media Center. To enhance their knowledge, they have to be subscribed, they have to be visit these channels about the different lectures. Those are recorded in this YouTube media centers. With this, I conclude and introduce today's lectures. Today, the professor, our resource person, Dr. As you already, he's not need to introduce more in this countrywide classroom teaching. As already sir has taken many classes in our first countrywide classroom teaching program, and he's a well-known person in the SRTM University for their subject chemistry and the PATHAN sir chemistry classes. So I welcome PATHAN sir to deliver his lecture on the atomic structure. PATHAN sir, I heartily, warmly welcome you and to inaugurate our this countrywide classroom teaching program 2022 with your valuable lectures for our student. Dear sir, please.
Okay, thank you, sir. Thank you for giving me opportunity to deliver a lecture at your platform. Thank you very much.
Yes, sir.
I thanks to the body, your principal, sir. Okay, so let us begin with the topic, that is atomic structure. Okay, now atomic structure is a part of syllabus in a BSc first year, second year. Okay, and we are delivering this lecture at BSc second year level. Okay. Excellent. Okay. So, in this unit, first point is Planck's quantum theory. Then another point after that is photoelectric effect. Okay, so one by one we'll discuss. So first point is Planck's quantum theory. See. Okay, so Planck's quantum theorem. So this topic belongs to BSc second year point. Now, so Planck studied black body. Okay, so black body is a body which can absorb 100% of a radiations incident on it. Okay, so after studying this black body by using old classical concept, we were all unable to understand this concept. At that time, by using old concept or classical concept, the classical concept said that the energy of the incident radiation is directly proportional to intensity. But by using this classical concept, black body radiations cannot be explained. So after studying Planck's, Planck proposed his own theory and proposed his theory, and that theory is known as Planck's quantum theory. And according to him, first point is, or first postulate of Planck's quantum theory is that the energy of, the radiations which pass from one body to another body, they pass in a discontinuous manner. Okay. Okay. So first postulate is, when atoms or molecule absorb or emit energy, they do so in a separate units of packets or in a discontinuous separate units of packets in discontinuous manner. Okay, so the separate units of packets are known as quanta. Okay, then second point of this theory is the energy of quanta is given by equation A is equals to h nu, and third point, the energy is shared in discontinuous manner. Discontinuous manner, and they do so in a whole number multiple of whole number multiple. Okay, see, so Max Planck in the year 1900 studied black body. Okay, according to old concept, the energy of incident radiation is directly proportional to intensity. But by using this concept, by using old concept or classical concept, the black body radiation cannot be explained. What happens in case of black body? As you increase temperature of this black body, the energy or frequency of emitting radiation continuously increases, and you cannot explain by using this concept, old concept. So by studying all this Planck's quantum theory, Planck's proposed Planck's quantum theory, according to him, energy is transferred in a discontinuous manner, not in a continuous manner. Okay, so in this way, this is a continuous wave, and energy is transferred in a different packets or bundles of a pulse of energies. This is first one, is the basic point or breakthrough for the century, we can say, because old concept says energy is transferred in a continuous manner. In electromagnetic radiation share energy in a continuous manner, but first time Planck proposed the concept of quanta. This is the base of quantum theory, or this is the base of Schrodinger's wave equation. This is the base of all the current quantum mechanics, the beginning of this. Okay, so according to Planck, energy is transferred in a discontinuous manner in a small packets of bundles of energies, and these are known as quanta. If you say singular manner quanta and the many quanta, quanta in many, quantum in small. Okay, then that was the first point. The second point is the energy of this quanta is given by equation E is equals to h nu, where this h is his own constant, that is known as Planck's constant. H is called as Planck's constant. Okay, and value of h is given as 6.626 into 10 to the power minus 34 joule second. That was actually proposed by himself. Remember, according to old concept, energy is proportional to intensity, but according to quantum concept, now energy depend upon frequency. Okay, now you can modify this equation as energy E is equals to Instead of nu, you can put nu is equals to c divided by lambda. So E is equals to hc. Sorry, c is equals to nu is equals to c divided by lambda. Therefore, E is equals to, it is hc divided by lambda. This is also one of the equation by using which you can calculate energy of a photon. Okay, so this quanta or photon energy transfer in a discontinuous manner, not in continuous manner. Energy of photon or quanta is given by equation E is equals to h nu. H is Planck's constant, nu is the frequency. Okay, and the third point, as we know that the energy is transferred in discontinuous manner, but energy transferred either as a whole number multiple of h nu. Okay, it will be transferred in 1 h nu, okay, or 2 h nu, or 3 h nu, or 4 h nu, and so on. So energy transferred in a whole number multiple of h nu, not in fractions. Okay, energy will not be transferred in fractions. That means h nu will not be transferred as 1.23 h nu, or 1.5 h nu, or 2.30 h nu, or any fraction number. Energy cannot be transferred in fractions. Okay, so always remember, energy or quantum is shared or transferred in whole number multiple or h of h nu. Okay, so this is the Planck's quantum theory. Okay, see once again, what is Planck's quantum theory? So Planck's in the year 1900 proposed a theory. Okay, that theory is called as Planck's quantum theory. Okay, then so this theory based upon the quantum concept. According to classical concept, energy E of electromagnetic radiation depend upon intensity. But if you take intensity as a proportional to energy, you cannot explain black body radiation. Okay. Then after studying all, Planck's proposed his own theory. That theory is known as Planck's quantum theory. According to him, energy of radiation depend upon frequency, and the first point is energy transferred in a discontinuous manner in the form of quanta or photons. Then energy of photon is given by equation E is equals to h nu, and energy as shared in discontinuous manner. So h nu will be shared in a whole number multiple, not in fractions. So that is all about Planck's quantum theory. Okay. Now we'll proceed towards next point, that is known as photoelectric effect. Okay. See. So what is photoelectric effect? Okay, so name suggests photo means light, electric means current. So the relationship between photons and electric current. Now what happens in this case? Okay, see. So okay, see. So photoelectric effect, that was actually discovered by Henrik Hertz in the year 1887, first time. Then later on, it is used in the burglar alarms and various purposes. Okay. Further study of photoelectric effect was done by Philip Lenard. So two people, Henrik Hertz and Philip Lenard, discovered this concept. Now, what happens in it? What is photoelectric effect? So, if you incident or shine electromagnetic radiation of sufficient energy, generally ultraviolet radiations, on surface of metal, so electropositive metals like cesium, sodium, potassium, lithium may be used in vacuum. So this setup is taken as vacuum. That means no air is present in. What happens? So when you incident electromagnetic radiations or light or beam of sufficient high frequency or energy, then the electrons are ejected from the surface of metal. Electrons are ejected from the surface of metal. This phenomena is known as photoelectric effect. Actually, that was discovered by Heinrich Hertz. Okay, see once again. So when a beam of light of sufficiently high frequency is allowed to strike a metal surface like cesium, sodium, potassium, or lithium, electropositive metal, in vacuum, electrons are ejected from the surface of metal. Okay, this phenomena is known as photoelectric effect, and these ejected electrons are known as photoelectrons. Okay, so previously burglar alarms were devised or made by using this concept, that is photoelectric effect. All people know that when you incident light on the surface of metal, sufficient energy light or UV light on the surface of metal, electrons are ejected and the current will pass through this emitter. Okay, so you must connect this plate to negative terminal, this plate to positive terminal. When incident light is okay, sufficient energy light is incident on the metal surface, electrons are ejected, then current will flow. So this is the base of burglar alarm. People were using this concept commercially, but no one have explained this. Okay, how this happens? Because previously the classical concept had said that the energy again depend upon intensity. So higher intensity, higher energy, lower intensity, lower energy. By using that concept, people or scientists at that time were unable to explain this concept. After the discovery of Planck's quantum theory, when Planck's quantum theory was proposed by Planck, in the year 1905, first time Einstein explained this, and he got Nobel Prize for this purpose. Okay, now what happens in photoelectric effect? See, so there are three different points or factors, you can say. Now what happens? First point is, if you increase intensity, as per an old concept, energy depend upon intensity, old concept. What happens if you increase intensity of this incident light on the metal surface? The number of ejected electrons increases, but their kinetic energy remains constant. That means if you increase intensity, the ejected electron number increases, but kinetic energy half mu square remains same. Okay, there is no change in their kinetic energy. But if you see old concept, if intensity and energy are related, then in that case, if you increase intensity, the kinetic energy must increase. But in fact, the practical observations said that if you increase intensity only, merely the number of ejected electrons increases, there is no change in kinetic energy. Okay, so that was the first point. So intensity just increases, number of ejected photoelectrons increases, but there is no change in kinetic energy. Okay, so that was the first observation. If you increase intensity of incident light, only number of ejected electrons increases, but there is no increase, no change in kinetic energy of the ejected photo electrons. Okay, so that was the first observation. Then if you increase frequency, okay, so frequency is increased. In that case, what happens? So when frequency is increased, when we observed the velocity or kinetic energy of the ejected photoelectrons, frequency increases, kinetic energy of the ejected electrons also increases. That was the second observation. Okay, so if you increase the frequency of incident radiation, then kinetic energy of the ejected photoelectrons also increases. Okay. Then if you decrease frequency, same. If you decrease frequency, the kinetic energy of the ejected electron decreases. And at one stage, okay, so critical frequency, or that is also known as threshold frequency. So below threshold frequency, okay, if you reduce frequency less than threshold frequency, it will stop emitting electrons. No, remember, intensity, and you may increase intensity to the highest possible level, but the frequency is less than nu zero or threshold frequency, no electrons were ejected. That means energy now depend upon frequency. Okay, so that was in brief photoelectric effect. Okay, see once again, what is photoelectric effect? That the photoelectric effect was studied, observed, discovered by Heinrich Hertz, and detailed study is done by Philip Lenard in the year from 1862 to 1947. Then, when a beam of light of sufficiently high energy incident on a metal surface, like electropositive metals like cesium, sodium, potassium, or lithium, electrons were ejected. Okay, remember you have to maintain vacuum condition. Okay, so electrons were ejected. This phenomenon is known as photoelectric effect. Ejected electrons is known as photoelectrons. Then further studies showed that if you increase intensity of incident light, incident photons, okay, then only number of ejected electrons increases, but there is no change in their kinetic energy. Second point, but if you change frequency, if you increase frequency of incident radiation, the kinetic energy of ejected photoelectrons also increases. If we decrease frequency, kinetic energy also decreases, reaches to minimum at nu zero. This nu zero is known as threshold frequency. And below threshold frequency value, no electrons were ejected. You may increase intensity to highest possible level. Okay. Then later on, till the discovery of quantum theory, no one was able to explain this photoelectric effect. Later, after using Planck's quantum theory, Einstein in the year 1905 explained photoelectric effect, and that is known as Einstein's explanation of photoelectric effect. Okay, see, so we'll discuss this, that is Einstein's explanation of photoelectric effect. Now what happens? So Albert Einstein in the year 1905 proposed one equation, that is h nu is equals to h nu 0 plus half mv square. Okay, that equation was proposed by Einstein. He got Nobel Prize for this. Okay, now see what happens. So when you increase frequency of incident radiation, energy of kinetic energy of ejected photoelectrons increases. Okay, but if increase intensity, just number of ejected electrons increases, there is no change in kinetic energy. Okay, so to explain all this, he proposed equation that is known as Einstein's equation of photoelectric effect. It is given as h nu is equals to h nu 0 plus half mv square, or it is also given as h nu is equals to w plus half mv square. This w is known as work function. This w is known as work function. Okay, now what is the explanation? What happens? H nu, according to Planck's quantum theory, E is equals to h nu, that is energy of this incident light or incident UV radiation is given as h nu. Okay, so the photon have energy of h nu. This h nu is used in two parts. One is h nu 0 and second is half mv square, that is kinetic energy. That means if you provide h nu amount of energy, it will be used in first removing electron from the metal surface, that is known as work function. The remaining energy is used to impart or increase kinetic energy of the ejected photo electron. This part. And it's just like someone gave you rupees, say 100 rupees. Okay. So 100 rupees out of that, say you are doing some work. Okay. To do that work, you need 20 rupees. Okay. So 20 plus 80. So to do that work, that is work function, you will require 20 rupees, and the remaining energy or remaining amount is used for the further use, that is kinetic energy. So work function is characteristic of each and every metal. So cesium, sodium, potassium, lithium, all the metals have their own discrete separate values of work function. What is work function? So this is the minimum amount of energy required to remove an electron from the metal surface. Okay. So therefore, work function is also is equals to W is equals to H nu 0. Okay. See once again. Einstein's explanation of photoelectric effect. So after observing data, the as the intensity increases, there is no change in kinetic energy, but number of ejected photoelectrons increases. Then as the frequency increases, kinetic energy of the ejected photoelectrons again increases. By observing all this and using the concept of quantum theory, Einstein proposed his equation, and that equation is given as h nu is equals to h nu 0 plus half mv square. Okay, or h nu is equals to w plus half mv square. This w is known as work function. This w is known as work function, or w is equals to h nu 0. Okay, this m is a mass of electron, and v is the velocity of these photoelectrons or ejected electrons. Okay, so this equation say that if you provide h nu amount of energy, some part of it is used to remove electron from the metal surface, that is known as work function, is given as w, and the remaining portion of the energy coming from this photon is used to increase its kinetic energy. Okay, we know threshold frequency nu is the minimum frequency that is required to remove an electron from the metal surface. Therefore, h nu is equals to h nu 0 plus half mv square. And after explaining all this, Einstein got Nobel Prize for this photoelectric effect, not for his theory of relativity. Okay, so he got Nobel Prize for this. Okay, any problem in this? Okay, then now let us go for the next, that is known as Compton effect. See, so see once again, in case of photoelectric effect, we use metal. Okay, so on metal surface, sufficient energy photons are incident, then electrons are ejected, and all this happens in vacuum. This can be explained by using this equation. Remember what I'm saying is metal, and on metal surface, UV light or visible light is incident in vacuum. Now what happens in Compton effect? Okay, see, so Compton effect. So Compton effect was proposed by, explained by A.H. Compton in the year 1923. Now see, what is Compton effect? So on graphite's surface, what is graphite? So graphite is a yes. Now see, what is Compton effect? So graphite is one of the allotrope of carbon. Carbon, coke, diamond, graphite, fullerene. Okay. So out of that graphite, it is an allotrope of carbon. What happens? So when X-rays of wavelength lambda, okay, when X-rays of wavelength lambda incident on surface of graphite, one of the photon of X-ray knock, okay, knock करतो म्हणजे strike करतो to the resting electron from the graphite, and electron is ejected from the graphite surface and X-ray is scattered with a longer wavelength. म्हणजे incident X-ray ची wavelength lambda असेल तर scattered wavelength थोडीशी वाढेल, it will be lambda plus d lambda, and electron is ejected or scattered from the surface of graphite. This effect is known as Compton effect. Okay, and okay, and this angle that made by incident X-ray and a scattered X-ray, okay, that angle is known as angle of scattering. So what is the similarity between photoelectric effect and Compton effect? In both the cases, electromagnetic radiations on the incident on the surface of, in that case, metal, in this case, graphite. Then they strike on the electron, electrons are ejected. In that photoelectric effect, electrons are also ejected. In Compton effect, electrons are again ejected. But in this case, in the Compton effect, the incident X-ray, which is having very high energy, scattered by some low energy photon. The change in energy or change in wavelength is given as d plus d lambda. So incident X-rays have wavelength of lambda, then scattered radiation or scattered X-rays will have longer wavelength, lambda plus d lambda. This phenomenon is known as Compton effect. Okay. See once again, when X-rays of wavelength lambda strike on a sample of graphite, the electrons were ejected. Okay, and this X-ray scattered by the longer wavelength. Okay, this phenomenon is known as Compton effect. The X-ray scattered by some angle, that angle is known as angle of scattering. Okay, this phenomenon is just like we play snooker or carom board. So in this snooker game, what happens? Okay, so these are the points in snooker. So in snooker, say this is your striker, and this is a ball. So striker came with the energy and strike the ball. What happens? Ball goes towards one direction. Okay, and the striker again move to another direction. Okay, but this time the scatter, so this ball or striker have low energy, and some part of energy is given to this ball, and ball will go in one direction. Okay, it is just like the photon of X-ray strike, knock electron present in the graphite, and electron is ejected. There's some energy, some part of energy of the photon of X-ray is given to the electron, electron is ejected, and photon is scattered with the lower energy or the longer wavelength. Okay, this phenomenon is known as Compton effect. Again, if you use old concept, that is energy is depend upon intensity, or classical concept, then you cannot explain Compton effect. But if you use current theory, that is Planck's quantum theory, that energy now depend upon h nu, energy depend upon frequency, or energy E is equals to hc divided by lambda, then you can explain this, that is known as Compton effect. Okay, now check. Okay. Okay, sir.
Yes, sir. Go ahead.
Am I audible, sir?
Yes, sir. Yes, you are audible.
Hello. Yes. Okay, so that was a Compton effect. Okay. Okay, sorry for disturbance. Now, as we said, there is a scattering of incident X-rays. The X-ray strike on electron. Electron is ejected in one direction and X-ray go in another direction with lower energy or longer wavelength. Okay. Then the increase in the wavelength, that is also known as shift in wavelength, d lambda, is given by equation that was actually proposed by Compton, is given as the shift in wavelength d lambda is equals to 2h upon mc into sine square theta by 2. 2h upon mc into sine square theta by 2. Okay, where h is Planck's constant, m is the mass, c is the velocity of ejected. See, so d lambda is a shift in wavelength, h is Planck's constant, c is the velocity of light, m is a mass. Okay, and this theta is the angle of scattering. Okay, now see, speciality of this or speciality of this Compton effect is the Compton effect cannot be shown by the metals like ferrous and other metals, because what happens in that case, if you incident X-ray of sufficient energy, the amount of energy required to eject electron is very high. Therefore, Compton effect is only shown by light elements. It is not shown by heavier elements. Okay. The next is de Broglie hypothesis. See once again, what is Compton effect? The energy, if X-ray of sufficient energy, X-ray incident on the graphite surface, X-ray knockout electron from the graphite surface, and it scatter or graphite surface scatter incident X-ray to some direction with some angle, that is angle theta. This angle theta is known as angle of scattering, and there is increase in the wavelength of incident X-ray and wavelength change by d lambda value. Okay, remember, as the increase in angle, as the angle increases, the value in d lambda is also increases. The highest possible value is shown at 90 degree. That means if X-ray of wavelength lambda is coming from this side and it's scattered by 90 degree, there is highest shift in wavelength, that is highest value of d lambda is observed at 90-degree angle. Remember, Compton effect is only shown by light elements, the elements which having lower atomic numbers. It is not shown by heavier elements. Okay. And next is de Broglie's hypothesis. Okay, see. So what is de Broglie's hypothesis? So before that, we have to see nature of electromagnetic radiation. Nature of electromagnetic radiation. Now what happens? If you see old theory, classical concept, according to that, electromagnetic radiations are waves. Okay, so we proved that they are waves. They have wavelength, they have frequency, they have wave number, they have amplitude. Okay, so electromagnetic radiations are waves. Then they show interference of light. Then electromagnetic show radiation, show reflection, then refraction, and many more. Okay, and various optical properties. Okay, all these radiation or all these properties were shown by electromagnetic radiation, and these properties prove that they are actually waves. Okay, so electromagnetic radiations are waves because they have wavelength, they have frequency, they have wave number, they show interference of light, they show reflection, refraction, different optical properties, they show diffraction patterns. Okay, so we know that electromagnetic radiations are wave in nature, but again, when you see photoelectric effect, or Compton effect, then the theory, quantum theory, so photoelectric effect, Compton effect cannot be explained if you don't consider it as a photon or particle or quanta. Okay, so the situation is now critical. Some say they are waves, but if you want to explain photoelectric effect, if you want to explain Compton effect, and according to quantum theory, the electromagnetic radiations are particle in nature. Okay, they are quanta, they have energy is equals to h nu, but they are particle. But these characteristics, these properties say that they are wave in nature. So to solve this, Einstein proposed that electromagnetic radiations have dual nature. Okay, electromagnetic radiations are dual in nature. They are sometimes waves, they are sometimes matter or particles. Okay, so Einstein suggested dual nature of electromagnetic radiation. Okay, so that was the first point or introduction to de Broglie's hypothesis. Now, by looking all this, de Broglie in his PhD thesis proposed looking at the dual nature of electromagnetic radiation. He suggested that as electromagnetic radiations are dual in nature, so the matter is also dual in nature, and the matter is dual in nature, therefore electron must have dual in nature. That means electron will have wave nature as well as particle nature. Okay, so looking at the Einstein's idea of dual nature, de Broglie in his PhD thesis proposed matter, that means electron is also having dual in nature. It is sometimes wave, sometimes particle. Now we know electron is a particle carrying negative charge and a mass 9.1 10 to the power minus 31 kilograms. Charge is 1.6 10 to the power minus 19 coulomb. Okay, and therefore electron is a particle. But according to de Broglie, he suggested that electron is also wave. Now then if it is wave, what is the wavelength? So wavelength is given as lambda is equals to h upon mu. M is a mass, u is a velocity, and mass into velocity is momentum. So h by p is a momentum. So lambda is equals to h upon p. This is nothing but de Broglie's hypothesis. Okay, see once again, what is de Broglie hypothesis? For that, we'll see nature of electromagnetic radiation. Electromagnetic radiations are waves. They have frequency, they have wavelength, they have wave number. Okay, they show interference of light, they show reflection, refraction, show different optical properties, diffraction. Okay, therefore they are wave in nature. At the same time, if you see photoelectric effect, the photoelectric effect, to explain this photoelectric effect, you must have to consider electron as a particle. To explain quantum effect, Compton effect, you have to use concept of particle for electromagnetic radiation. That means they are particle here in photoelectric effect, in Compton effect, but they are waves here. This property show they have wave nature. Therefore, Einstein suggested that electromagnetic radiations are dual in nature. Okay, then looking at this, then de Broglie proposed his own theory in his PhD thesis. He proposed that as electromagnetic radiations are dual in nature, so electron is also dual in nature. Okay, and we know electron is a particle. Okay, its charge is 1 into 10 to the power minus 19 coulomb, and the mass 9.1 10 to the power minus 31 kilogram. Then he proposed it as a wave, and the wavelength of this electron or moving electron is given as lambda is equals to h upon mu, or lambda is equals to h by p. This is known as de Broglie's hypothesis. Okay, this is known as de Broglie's hypothesis. That is lambda is equals to h by p. Then now he derived this equation by using Einstein's mass energy relationship and again Planck's quantum theory. Now what he says? So according to Einstein's, energy E is equals to mc square, and according to Planck's, energy again is equals to E is equals to h nu. Okay, therefore, so from equation number 1 and 2, h nu is equals to m into c square, but you can replace this nu as nu is equals to c divided by lambda. Therefore, it is hc divided by lambda is equals to mc square. Cc cancelled. It is h by lambda is equals to m into c, or simply lambda is equals to, okay, lambda towards this side, mc towards this side, h upon mc, and replacing this last c by velocity mu. In this way, he derived this relationship, that is lambda is equals to h upon mu. So E is equals to mc square is accepted concept. Okay, then Planck's quantum theory is also correct. E is equals to h nu. So using this, he proposed the wavelength of moving electron train is as given as lambda is equals to h upon mu. So h is Planck's constant, m is a mass. Okay, mass of electron, u is the velocity of electron. Now you can apply this equation to anything. You can apply this to electron, proton, atom, fast moving particles. Okay, so this equation is known as de Broglie's equation, and this overall thinking is nothing but de Broglie's hypothesis. Okay, then later on, two scientists they try to disprove de Broglie hypothesis. So they think that de Broglie hypothesis is wrong. It is just impossible that how electron can be a particle or wave at the same time. Electron is a particle, it cannot be a wave. So they proposed one experimental setup, okay, and that is known as Davison-Germer experiment. They tried to disprove de Broglie's hypothesis and proposed one experimental setup that is known as Davison-Germer experiment. Now, what is that? See. Now, what is it? So they set up this experiment as like this. So this is heated filament through which electrons will be ejected. Electron will strike on nickel crystal. Then the nickel crystal will diffract all that electrons in certain directions. Okay, with some angle. To measure angle, they use this D. Then to control the velocity of these ejected electrons, they again set up. So this is a slit through which electron will be filtered, and this is the setup by which electron will gain high energy. Okay. Then here at this location, electrons were collected, and this set is known as collimeter through which electrons were collected. Now, this is in brief a setup of Davison-Germer effect. Okay, then we'll conclude. Now, first thing, if now basically our target is lambda is equals to h upon mu is correct or wrong. Okay, to prove that this setup was set, that is Davison-Germer's experiment. See one thing, only 2 points. Point number one, if on the surface of metal like nickel, this is one block of nickel crystal, on nickel crystal, if X-rays were incident, see, very clear point, on the surface of nickel crystal, if X-rays were incident, then nickel will show diffraction. Okay, nickel will diffract these X-rays and it will show diffraction pattern. That means X-rays will show diffraction. Okay, and they are diffracted by nickel. So one criteria is waves are those which show diffraction. Anything which will show diffraction is a wave. This is criteria. Okay, are you getting all this? Only one point to understand this Davison-Germer's experiment. The setup is okay, no problem with the setup. The concept is anything just like X-rays or any kind of electromagnetic radiation, anything that will show diffraction when incident on a metal surface, anything that will show diffraction is wave. Okay, that means if from here, from heated filaments, the ejected electrons will get incident on the surface of nickel. If they show diffraction, they are waves. If they don't show diffraction, they are not waves. This is the basis of Davison-Germer's experiment. Are you getting point? See once again. So what is the criteria? They want to disprove lambda is equal to h upon mu. They are not agree with the de Broglie hypothesis. Okay. Then, so what is the base of this experiment? Just like X-rays, if X-rays incident on the metal surface, it will show diffraction. So anything which will show diffraction pattern when incident on the, say, in case nickel crystal, just like X-rays show diffraction pattern, anything that will show diffraction pattern are waves. Now what happens? So they kept here 50 volt of current. Okay, so electrons are accelerated with the 50 volt of energy. Okay, then the angle through which this collimator collected electron was 50. So electrons are ejected from the nickel surface and the diffraction angle was 50 and electrons were diffracted. Okay, and the diffraction is collected in the collimator. Overall, what I am trying to say is, just like X-rays, as X-rays show diffraction, electrons when incident on the nickel surface also show diffraction. Electrons also show diffraction. That means electrons are wave in nature. Okay, that's it. So they proved, they gave biggest experimental support to de Broglie's hypothesis. Now de Broglie's hypothesis is not hypothesis, this is truth. This is now called as de Broglie's equation, that is lambda is equal to h upon w. Okay, so we'll stop here.
Sure.
Sir.
Thank you, sir. If the participant have any questions or query, they can ask their queries to Dr. Pathan, sir.
Yes.
पार्टिसिपंटला काही क्वेश्चन असतील तर त्यांनी सरांना विचारावे. आपण हात रेस करावा, आम्ही आपल्याला अनम्यूट करू. ज्यांना काही प्रश्न विचारायचे आहेत.
Anyone?
Yeah. विद्यार्थ्यांना काही प्रश्न विचारायचे आहे. I think that topic is all clear. They
Okay, sir.
understand very well.
So thank you, sir, for giving such an opportunity.
Yes,
so I must, I will leave here.
Yeah, just wait a moment, sir.
Because I have a meeting.
We'll do one more vote of thanks for this session, and
Okay.
we also schedule another session
Tomorrow.
Tomorrow. So our participant will join at the 2 p.m. tomorrow in the noon session. I didn't get the topic that you will be covered tomorrow.
Chemical kinetics.
Yeah. Okay.
Chemical kinetics in that particularly we'll discuss opposing reactions.
Okay, sir. Dear student, tomorrow Pathan sir will deliver his lecture.
BSc third year.
Yeah, BSc third year on the topic chemical kinetics. And now, I firstly thanks to Dr. Pathan sir for joining this countrywide classroom teaching program continuously since last year, and he's trying to deliver more 2 or more lectures in this countrywide classroom teaching program. I, from bottom of my heart, I thanks and welcome you, sir, in this countrywide classroom teaching program, hoping you will be available whenever we need you.
Anytime.
Yes, sir. Now, I handed over this session to the head department of chemistry, Dr. Gajanan Kuttapalli, sir, to propose the formal vote of thanks for the first session of this countrywide classroom teaching program 2022. Dr. Kuttapalli, sir, over to you.
Thank you, Dr. Arvind Chauhan, sir. So I am very happy to present the vote of thanks of today's countrywide classroom teaching program 2022, organized by Digambar Rao Bindu Art, Commerce and Science College, Bhokar. So in today's session, Mr. Pathan sir has explained topic of BSc second year, that is atomic structure, in which he has explained the Planck's quantum theory, photoelectric effect, Compton effect, de Broglie hypothesis, and Davison-Germer experiment in very simple and understandable language. So I hope all participants understand all these points, and I'm very happy to say thanks to Mr. Pathan sir for delivering and giving time for us and for our student. So thank you very much, sir. And I also thanks to Dr. Arvind Chavan sir, IPC coordinator of our college, for organizing such a nice activity, that is countrywide classroom teaching program. In last pandemic situation also, we have completed a number of lectures, and in now from this pandemic situation also, we are going to arrange different lectures on countrywide classroom teaching program. So I once again thanks to Mr. Pathan sir for giving time and enlightening us for their knowledge. And thank you all the participants for joining this online class. Thank you very much, all of you. And with this, I conclude that the session is over. So thank you, all of you. We will meet again tomorrow at 2 p.m. with new topic.
Thank you, sir. The session is over for today. We will meet tomorrow at the 2 o'clock noon. Thank you.